Watching the morning show from your local news leader.
Welcome back to the morning show.
It's Wise Guys Wednesday, and Matt Sellens is a physics professor from the U of I, and he's joining us today. So, Matt, what are we learning about today?
Well, last time we talked about floating and sinking, the last couple of times, and so the question came up about states of matter. So the differences between solids and liquids and gases. And so I want to talk about that because it's sort of interesting. And so let's start with the difference between gases and liquids.
Okay.
Okay. So suppose these two things I'm holding in my hand, these racquetballs, were atoms.
Okay.
Right? If they were in a gas, they'd be pretty far apart. They'd maybe be like this far apart.
Okay.
Okay. And then the question is, in a liquid, they're kind of closer together. All right. And so that means that a liquid takes up less space than a gas. So if I take this balloon, which I just blew up, it has air in it, and I'm going to put it into this little bucket, and this little bucket here has liquid air in it. It's very cold. Liquid nitrogen is at 77 degrees Kelvin, which means that it's cold enough to take the air in this balloon and turn it into a liquid.
Okay.
So I'm going to shove this balloon into this very, very cold liquid, which is in this thing called a dewar. And what you're seeing happen, if you look at the top of this balloon a little bit, see, it looks like the air is leaking out, but it's really not leaking out at all. The air that's in this balloon is just turning into a liquid, and the liquid takes up a lot less space than the gas does, and so it kind of deflates the balloon. So in a second here, I'm going to pull this out, and I'm going to show you what's in the bottom of the balloon, what's left over. Okay, so if we go like this now,
Oh, wow.
see, there's a little puddle in there. Okay, see the little puddle? That is a puddle of air. Wow. Okay, so you can guess how much smaller the liquid is than the gas just by realizing that if you go from,
There. Oh, warming
okay,
back up.
so the atoms in a gas are about 10 times farther apart than the atoms in a liquid.
Sure.
And so since we live in 3 dimensions, that means that we get 10 times 10 times 10. So the density of this liquid is about 1,000 times the density of the gas at the pressure in this room. Okay, so that's thing number one. Then the next question is, what about the difference between liquids and solids? So let me ask you guys, what do you think about if you have atoms of a liquid and atoms of a solid, how do they compare in closeness together?
Well, the solids are going to be much closer.
Solids are going to be closer, and that's what everybody thinks. But in actual fact, think about this. What happens to water when you freeze it? Does it float or sink afterwards?
Sinks.
Ice, does it sink in water?
To the top?
Floats.
It floats, doesn't it?
Hey, I didn't pay attention to the science
Yeah,
class.
so that's a tricky question. So in fact, the ice atoms are a little bit farther apart than water atoms in a liquid.
Okay.
And so in general, the atoms in a liquid are about the same distance apart as in a solid. And that's, people don't really think about that. But basically, so if this is a solid, we have the two atoms, they're stuck together. If it's a liquid, they can move around each other a little bit. They have flexibility. And the way I show this with little kids, right, is if you have a room full of little kids, you pack them together and they hold their arms down. They can move around each other like this. That's kind of like a liquid, see? Right. I can go all the way I want. But if you get them to hang on to each other's arms, then they're stuck together. That's more like a solid.
Okay.
So then if you take a solid or a liquid and you make it really cold, let's see what happens. So I'm going to call this piece of greens a liquid because it has a lot of water in it.
Okay.
If I put it in this liquid nitrogen to make it very cold, I'm going to shove it in there. Okay, let's see what happens if I pull it out. Okay,
Oh.
see, so it just breaks.
Do I get to use
falls
this now?
apart. Oh, you do, yes, because we're going to do the same thing with a banana here in a second. So this banana is not frozen. Why don't you give that a smack?
Here we go. Gotcha.
One more. Give him
One more?
Okay, very good.
You guys.
Okay, now I'm going to take this. There's a banana in here that's been frozen.
I'm not sure if we can go on.
Now that is a frozen banana. That was pretty great.
Cindy, where are you going? I'm sorry.
You got me. You got me too. Except you can't tell on my shirt because it's already kind of, you know. Okay.
This is great. All right.
great.
So do I take it easy on this thing?
You can take it a little easy, but
All right.
that one's frozen.
Okay.
See? And the last thing we're gonna do is I have a racquetball, right?
Okay.
Which is pretty bouncy. I've had one that's been sitting in here for a while. It's very cold now. We're gonna whack that one.
Do you want to try this time? You want to take a go at it?
So give that a whack with a hammer.
Oh. Should I? Is that supposed to hit it harder?
Give it a, yeah.
Oh,
There you go. Well done.
well done.
Now, you notice that sounded almost like breaking glass?
Yeah, it really
It kind of was, because this stuff is really, really stiff. Now, this stuff doesn't hold much heat, so I can actually touch this without freezing my fingers. But as soon as this stuff thaws out, see, it gets rubbery and it gets loose again. So basically, if you have a solid where things are joined together like you're holding hands, and you make it very cold, it's like you're holding on really tight, right? So it's very hard to move, and so it's brittle. But after it thaws out again, things are holding on kind of loose. It's like you're holding hands with somebody. You can move a little bit. You can go like this.
Very cool.
So there you go. So the question for next week,
Okay.
I can just happen really quickly, is that how do we, we're talking about atoms for the last 3 weeks. How do we actually know atoms exist? We can't see them. So that's the question. We're going to dive into
Explore.
that science a bit next week. Yeah.
Are you bringing this back?
I could if you want.
Okay.
Maybe she could smack something.
Yeah, we're gonna have
like an apron or something.
It's like a Gallagher show right
I
here.
think Cynthia thought that was head after.
Matt, thanks. We'll be right back with more of The Morning Show.
I'm sorry.